So we're on Unit 3, Day 2. Unit 3 is polynomials. Yesterday we worked with naming them, putting them in standard form, doing all those different types of things. Today we're going to add, subtract, and multiply polynomials. We'll do dividing on Monday. So again, whole goal by the end of the hour is to be able to add, subtract, and multiply polynomials, which you've done. It's nothing new. But now instead of having maybe a binomial times a binomial, you're going to have a binomial times a trinomial. And we'll show you a method for doing that makes that nice and easy to do. So adding and subtracting polynomials, best way to do these is just to go. So when you add and subtract polynomials, none of the wording needs to be done. There's no sense writing that. Just kind of write down the problem. When you add or subtract polynomials, you combine like terms. That's all you have to do is combine like terms. When you're adding, parentheses don't matter. You can just essentially get rid of the parentheses when you're adding. When you are subtracting, that's not the case. When you're subtracting, like we'll do in the second example, we're going to have to worry about distributing the negative into all of the other spots. Okay, so in question number 1, I'm just going to ignore that they're even there. What I like to do and how I like to do these is I like to underline these. And what I do is I underline them the number of times that the exponent is. So I'm going to put 3 underneath that because it's a third degree monomial. 9, it's a 0 degree. I'm not going to put any lines under it. X is a first degree. I just put 1, 2, none, 1, 3. And the reason I like to do that is because I have to put it in standard form. Now putting it in standard form, I just have to go 3, 2, 1, none. So I look at my ones that have 3 lines underneath it. I've got 2x cubed and I've got x cubed. So I've essentially got 2 apples and I add another apple. That gives me 3 apples. So I have 3x cubed. So my x cubes are done. If you have to kind of scratch those out so you can ignore them at that point, you can do that, but you don't have to. Now I look for 2 lines. That's the only one that has 2 lines, so I just write it down. Nothing to combine. If you have to scratch it out, scratch it out. I look for 1 line. I've got negative x plus 7. So negative 1 plus 7 is 6. Plus 6, scratch them out. Now I've got no lines. 9 plus 4 is 13. That's my solution. I'm done. Nothing left to do. That was quick. Good. Can add? Adding a problem? You've done this before, right? Now, when you subtract, subtraction tends to be the one that becomes the issue a little bit. When you're subtracting, the first set of parentheses in the first one, they don't matter. My suggestion is anytime you have a subtraction symbol, subtract. Rewrite it. So we're going to put 3 minus 2x squared. Now, we're subtracting this whole thing. So that means we need to distribute that negative into each of the terms. So this becomes negative x squared minus 6 plus x. Now I have it in a form. No lines, 2 lines, 2 lines, no lines, 1 line. And again, this is just the way that I like to do it. If you've got a better way, if you like to highlight, highlight. If you don't need to do it, then it's whatever. So we've got negative 2x squared minus x squared. So negative 2 minus 1 is negative 3. So that's negative 3x squared. We've got a positive x. And we've got 3 minus 6. It's negative 3. That's your solution. You move on. You're done. Okay. Any questions with that one? All right, the next one. Again, we're subtracting. So because we're subtracting, I'm going to rewrite it. Notice I didn't rewrite the addition ones. No need to. I am going to rewrite this as negative 2x squared y plus 5xy. And you notice that there was a little pause in there. I almost messed it up. So sometimes it helps to draw the lines in there to remind yourself to distribute, because everybody always does the first one. That's what I did. And then I had to pause there for a second because I almost put minus 5x. I forgot to distribute. So putting those lines in there sometimes is just that extra reminder that we need to make sure that we distribute that part in there. Now this one, what standard form? This one's a little bit standard form. We really don't worry about too much in standard form. I like to start with the x squareds. Identifying which ones are the same can become a little bit more difficult with this. I would probably find a highlighter if I had one, and I have one. So I've got x squared y, and there's x squared y. I've got 2xy and 5xy. I've got negative 3xy squared, and so there are my like terms. And I just combine them. So I combine the greens, 3x squared y. And remember, variables and their exponents remain exactly the same when you're adding and subtracting. That doesn't change. Plus 2 plus 5 is 7. Negative 3 minus 8 is negative 11. And that's your solution. Again, I've got a highlighter sitting here. Circle, underline, do whatever it is you need to do to make it work for you and whatever works best. Adding and subtracting. Any questions with adding and subtracting? Everybody's good? All right, then we get to multiply. So we get to find each product. Product means just to multiply. And again, stuff we've done already. In this case, we've got a monomial times a trinomial. What do? How am I going to solve this one? Distribute. So we're going to distribute. So I have to take 4y squared times each of those. So 4y squared times y squared. Numbers times numbers is 4. Remember, when we do variables with exponents, we add the exponents. So it's y to the 4th. Now we've got 4y squared times negative 5y. So 4 times 5, negative 5 is negative 20. Y squared times y, there's understood to be a 1 there. 2 plus 1 is 3. 4 times 3 is 12. We bring the y along for the ride. There's your solution, and you're done. Again, done that type before. That's nothing new. Same thing with number 5. Nothing new. Remember, we FOIL or distribute, double distribute. So if we got x plus 3 times x minus 4, I have to take x times both of those terms. X times x is x squared. X times negative 4 is negative 4x. So that's my first. That's the inside. Or I guess that's the outside. But now I have to take the 3 times both of them. 3 times x is 3x. 3 times negative 4 is negative 12 probably. Now combine like terms. So we've got 2 and 1. So x squared minus x minus 12. Again, something I would expect you guys already to be able to do. That's just kind of a quick reminder of how those go. Why don't you go ahead and do number 6. Do number 6 quick, and then we've got 2 more after that, or maybe 3, and we should be good. Okay, so if I take x squared, xy squared times y squared, that should be xy to the fourth. Minus 5xy to the third plus 3xy squared. Questions with that one? Everybody okay? All right, so the next type then we have to look at is okay, what if we have something like this? What if we have a binomial times a trinomial? So there's two ways to do this. One way to do it is you can think of it as just distributive property, just like we did. And don't write this down unless we could do the distributive property. We could take a times all of those and then -3 times all of those. That's one way to do it. And it works great. You can get this long chain. Another way to do it is use box method to do it instead. And the box method is just a little bit of a better way, I think, to organize it. You'll notice that I put 2 rows and 3 columns. Now, if I've got my 2 rows, that means the A is going to go there and the -3 is going to go there. And then the 2, -5a, and the a squared go on the columns. And if you flipped it around and did 3 by 2, it's fine. It doesn't matter. Now, how do you get what's inside the box? You multiply the row by the column. So the column is 2, the row is a, 2 times a is 2a. So 2a goes right there. I'm just going to keep going down the column. So 2 times -3 is -6. So I've got my first column done. Now I'm going to go to the second column. So a times -5a is -5a squared. -3 times -5 is 15, so that's 15a. Does everybody see what I'm doing? So a times a squared for our last column is a cubed. -3 times a squared is -3a squared. So now I've got my whole box filled in. Now I just start looking for like terms. I've got an a there and an a there. I've got a squared and a squared there. And I've got an a cubed, and then I've just got a number. So we want to put it in standard form. So I want to put my a cubed first. So it's just a cubed. I've got -5a squared and -3a squared. Now we're just adding these. So -5 and -3 is -8. That's -8a squared. We've got 2a plus 15a, which is 17a. And then -6. I just think the box method works better. It's easier to organize. I think it's easier to organize. But if you like to write out the whole thing, that works too. It's whatever works best for you. It's the same exact thing. It's just a different way to store it. Okay. Questions with that one? And again, I think we're just kind of doing things we've done before. Trinomial times a trinomial, and we're not going to do this one. I think we're okay, but you would just do a box, and now your box would just be a 3 by 3, and you would just do the box thing. Make sense? Okay. And then the last one that I do want to do, and I do want to do this one. A plus 3 cubed. Remember what it means when you're cubing something. When you're cubing something, it means you're taking it times itself 3 times. So this has to be rewritten as a plus 3 times a plus 3 times a plus 3. Now we're going to erase evidently. We're going to do that part first. So we're just going to FOIL that and see what that turns into. So we've got a times a is a squared. I've got a times 3 and 3 times a. So I've got 3a plus 3a is 6a. Again, I kind of skipped a little bit of a step in there, but I just took the middle terms. A times 3 is 3a, 3 times a is 3a, 3 plus 3 is 6. That's 6a plus 9. Now I have a trinomial times a binomial. So then since I have 3, now I'm going to take, and I'm going to do the box method for this now. So I've got 3 going along the rows, so a squared, 6a, and 9, and a and 3. A times a squared is a cubed. 6a times a is 6a squared. 9 times a is 9a. Second column, 3 times a squared is 3a squared. 3 times 6a is 18a. 3 times 9 is 27. Combine like terms. Those are like. Those are like. Those are like. And 27's on its own. Again, this is a nice thing about it too. Generally speaking, it's the diagonals that you can combine. 6 plus 3 is 9. 9 plus 18 is 27. And there it is. That's your solution. Adding, subtracting, and multiplying polynomials. Something you've done before. The only new thing might be the box method, but I think we've talked about that before as well. Maybe at the beginning of the year, we may have talked about this as well. Any questions before we move on? Look at that. We're done. Last time you have to listen to me for almost 3 weeks.